So last class we discussed about again master slave configuration, how to delete the raise around conditions, what are the differences between flip flop and latches. These all things we discussed last class, right? So now we'll go with So in VLSI, chips, okay, whatever the chips we are manufacturing, in those chips, which kind of flip flop they will use, okay, how the timing arcs they will observe. These things today we'll discuss. So generally the VLSI, so generally they will use mostly D flip flop they will use. D flip flop they will use in the VLSI chips. So input D will be there, clock pin CP will be there, Q will be there, Q bar, and loadout set, reset. These things will be there. Okay, these things will be there. When outside V box, if you are observe, it will be looks like this. But inside, when you are open this V box, inside how the gates will be made, the gates will be looks like this. The transmission gate will be there. So then inverter, this inverter will be connected to here. And one more transmission gate will be there. This is the Q. This is the Q. So now this is the transmission gate T1. This is transmission gate T2, T3, T4. So whatever this terminals will be there. So whatever this one is there, this one CLK, this one is CLK bar, CLK, CLK bar, CLK, CLK bar, CLK, CLK, CLK bar. So this is CLK bar, this is CLK. This how actually your flip flop will be looks. So later they will replace this inverter with the NAND gates that we'll discuss later. So just to see how the timing arcs will be. So what are the things we need to be take care when we are reading the data and writing the data and reading the data. So two things will be happen. Means we will set the data into the flip flops and we will get the data from the flip flop. These two things will happen. So these two things, how it will happen, we'll see. So what is the use of this transmission gate? So transmission gate uses both NMOS and PMOS together. They will make. Okay. So one will be PMOS will be there, one NMOS will be there. So what it will do? If signal is 0, NMOS will be turned on and output signal will make stronger 0. If signal is 1, PMOS will be turned on and output signal will make stronger 1. Means whatever the signal will come at the D pin, the strongest signal need to be passed to this inverter 1, and inverter 2. Okay, inverter 1, inverter 2, like that. Inverter 3 and inverter 4. So now I'm going to discuss basic concepts of STA, static timing analysis, STA. Very important focus. Very important. So now, if you observe here, so how the operation will be means when T1 turn on, T1 on, T2 off, and T4 also on, and T1 and T3 will be off states. So now So these both will goes to off state. So quite opposite, T3 and T2 both are on. T1 and T4 will be off state. Both are will be off state. So now how it will be means when clock when I am giving based on the clock positive level, negative level, this transmission gates will be turned on. This transmission gates will be turned on. So now I am giving the data D equal to data I am giving data D equal to 0. So now based on this transmission gate T1, first condition, okay, based on the transmission gate T1 is turned on. Transmission gate T1 is turned on, the output here we are getting 0. The output we are getting 0. So after that, this inverter 1, whatever the 0 input is there, the 0 input it will take, it will make 0 to 1 inverter. This 1 it will go, this one is off, right? When T1 is on, T3 will be off. So then it will goes 1, it will goes to here and it will convert to 0. So the travel time from the D to, okay, inverter 2. Okay, so the signal which is travel from D to inverter 2. Up to it is go to the inverter 2 only, then I can say that my data is stored. Okay, I can guarantee that my data is stored. After inverter 2 it is reaching. Okay, if it is inverter 2 also turn on, then I can say my data is saved. My data is stored. So this transmission T1 time turn on, T1 on time plus inverter 1 on time plus inverter 2 on time. These are the 3 times which is required, okay, so to be save the data, T1 time on time, inverter 1 on time and inverter 2 on time. These are the 3 required times which is required to be save the data, whether the data is 0 or 1. After that what happens? So the level will be changed. Okay, for suppose consider this is the negative level, this level is completed. Now 0 it reaches to here. Immediately positive level will comes. This one will goes to off state. T1 will be goes to off state. T2 will be turned on and T3 will be turned on. T4 will be off state. So now T2 will be turned on. Whatever 0 is there, this 0 will goes to this side. Okay, 0 will goes to this side. Inverted. Okay, with the T3 through T3 inverter 4. So then it will reach to output. Inverter 4, inverter 3, it will reach to output. So this is the thing happens. When it is going to output, it will goes as well as inverter 4 also. It is goes to the output as well as inverter 4 also. Again next, okay, negative level will comes. Okay, so this one will be turned on and this one will be turned on. Okay, this will both will goes to the off state. Okay, this one will be latched, previous data will be latched. It will keep on giving the previous data. So here one more data is start storing. One more data start stores here. So this is the process will happen. So in this process, if you observe, see, there are 2 problems are there. So when 0 when I am giving, so here 0, no doubt. But for suppose consider when it is going to off state, so here this is 0, right? So for suppose previously it is 1, this one is coming here, this one is 0, this one is 1. If both the different signals are coming to one input of a gate, one inverter, so one is 0, one is 1. Inverter is there. This inverter, I am giving 0 and 1. Which one it will take? We don't know, right? So if I am giving 0 and 1, which one it will take? We don't know. So this case can be happen. Because of that, so whatever the data we are giving, the data may not be captured properly. That is the problem we will get here. That is the main problem we will get here. So we will see 2 types of timings. We need to ensure that our data, whatever we are storing into the flip-flop, that is okay properly stored. And so and it is properly stored. We need to be confirm that. To confirm that, we need to be confirmed two timings. One is setup time. Setup time. Second one is hold time. Setup time and hold time. These two times we need to be confirmed. One is setup time we need to be confirmed. Other one is hold time need to be confirmed. What is setup time? What is hold time? We'll see that. This one is clear. Any questions here? The same circuit you can represent in the NAND representation also. I will show you how the NAND representation. The same circuit. Transmission gate. Transmission gate T1. Input D. So this is T2, T3, T4. So it will be like this. This is inverter 1, inverter 2, inverter 3, inverter 4. Yeah, I will repeat. I will repeat here. Focus. Focus, guys. Focus. So this one will be Q bar. If someone will taking, okay, Q bar will ask and want to be mentioned. So this is the Q bar, that is the Q. So now, if you observe here, what we are doing means, so a flop is there. The flop will either we will store the 0 data or 1 data. Two data we will store. Well, is for suppose consider, so I am getting, okay, the flop input I am getting data 0. Data 0 I am getting to the flop. When I am getting data 0 to the flop, okay, so what is the process will happen? If the clock pulses are like this, if the clock pulses are like this, if the clock pulses are like this, in this clock pulses, if this is master slave configuration, this first half will be master, second half will be slave. Both are D latch. Okay, both are D latches. Okay, so that's why, okay, so master whatever the data will give, slave will follow that one. Slave will follow that one. For suppose master will be turned on at negative level. Okay, master will be turned on at negative level. Okay, slave will be turned on at positive level. For example, if you consider this is the master turn on time. Slave will be turned on at positive. This positive level slave will be turned on. So when master will turn on, which transmission gate will be turned on? T1, transmission gate T1 and T4 turn on. And slave will be turned on. Transmission T2 and T3 gates will be turned on. So in this condition, which one will be turned off? T2 and T3 will be off state, and here T1 and T4 will be off state. Okay. So these are the master and the slave. So when it will turn on, so now you got the clarity. So when data is zero, so whether the data is 0 or 1, transmission gate T1 is turned on. Okay, turn on. Okay, the whatever the data D is there, this data will be passes through this transmission gate T1. The data 0 will be reaches to here. So now I can say my data is stored. No, I can't say my data is stored until unless it should be passes through this inverter 1. When it is passing through the inverter 1, it will generate 1. But it can't go to this direction because it is off. It will not go to this direction, it will go to this direction. So this is 1. So this output, it is passes to inverter 2, it will become 0. Now it is data is stored. Okay. Now the data is stored. So whatever the time taken for to reach after this inverter 2, this signal, whatever the time taken to reach from D input to this inverter 2, output, whatever the time it is taken, right? That time only we will call the setup time. That time only we will call the setup time. T setup time. T setup time equal to T setup time equal to T1 transmission gate T1 on time plus inverter 1 on time plus inverter 2 on time. Inverter 2 on time. This is the setup time. This is the setup time. In the equation format, if I want to say, this is the setup time. But in the definition format, if I want to say, what is the setup time? If someone will ask, what is the definition point of view? If I want to say, the minimum time which data should be stable, the minimum time which data should be stable before active edge of the clock. Before the active edge of the clock. The minimum time data should be stable before active edge of the clock. See, when the data is reaches from 0, here 0, so whatever signal 0, then it becomes 1, then it is reaches to here and 0. When it is traveling, in that condition only, data is changed. Means 0 becomes 1. So then whether it will store the 0 data? No, right? So that's the thing only. Before active edge of the clock, this edge, before this edge, data should be stable. Certain time data should be stable. What is that certain time data should be stable? Transmission T1 gate on time, inverter 1 on time, and inverter 2 on time. These three gates on time, so data should be stable. That is the setup time. What is the setup time definition? Someone asks, the minimum time data should be stable before active edge of the clock. Before this active edge of the clock, minimum time data should be stable. What is that minimum time? How they will decide that minimum time means this T1 transmission gate on time, inverter 1 on time, and inverter 2 on time. In this process, if anywhere data will be changed, so then their setup will be fails. In this process, anywhere data will be changed, setup will fails. Or time is not stable, so means this minimum time is data is not able to stable, so then setup time will be fails. Setup time will be fails. This is the setup time. Any questions, any notes here? Setup time means until unless data go to the latch mode, until unless data go to the hold mode. So I can say that the whatever the time taken to be go to the data to the latch mode, so that time only setup time. See, these are the clocks. CLK bar. So these are all. This is CLK. This is CLK. These are all clocks. These are all clocks. So before this clock edge, so the data should be stable. Before that clock edge itself, data should be stable. So that time only called the setup time. setup time. The reference I am repeating again, very important. The minimum time, okay, data should be stable before active edge of the clock. That we will call the setup time. The setup time equation is transmission gate on time, inverter 1 on time, inverter 2 on time. This is the minimum time. Means this all together will call the setup time. Setup time. So now what is the hold time? T hold time. Hold time. I will give simple examples. Later I will give the examples. Don't worry. You can understand very clearly this topic. So T hold time. What is the hold time? Hold time means, okay. Now for suppose consider this transmission gate, okay, process is completed, okay, it is go to the inverter 2, output is 0, it is reaches to 0. Now next slave is turned on. Slave is turned on, T1 will be turned off and T3 will be turned off. T2 and T4 will be T2 and T3 will be turned on. T1 and T4 will be turned off. So in this condition, what happens? If you observe, this one and this one will be turned on, this one and this one will be turned off. But my question is, okay, any circuit, immediately it will go to the off state. Immediately it will go to the off state. When I given the signal, okay, when it is reaches to this negative level, okay, negative level, immediately this transmission T1 gate will be off. No, right? So it is slowly it will be off. It will have some response time. Every circuit in every combinational circuit, every combinational gate have some propagation delay. Means turn on time, turn off time will be there. So when it is going to off case, okay, this T1 is going to off case, one more data is entered. For suppose one data is entered. Here it is 0. This is 0. This 0 is passing to this. The 0 reaches to here. Here one more data is entered when it is going to off state. Like so you will see in many movies, okay, when gate is closing, hero will be entered, right? The same way here also, this T1 is turn off condition only. So one data is fastly came and entered inside. So now this is 0, this is 1. Which data it will take? This inverter 1, which data it will pick? Either 1 it need to pick, either 0 need to pick. Or it will pick both. It can't pick both, right? So means it is undefined condition. Means, okay, metastability state. Neither 0 nor 1 case will be counts. Neither 0 nor 1 case will be counts. So means even though the setup time we will meet, we can't guarantee that our data will be remaining the same whichever we given. Even though setup time it is met. So how I can guarantee that? So after setup time requirement it is made, okay, this transmission T1 time completely go to the off state. Completely go to the off state. It should not overwrite with any other data. It should not overwrite with any other data. So then I can say that my data is stored properly. My data is stored properly. Means whatever previously D0 data I given, that is stored properly. No other data can be overwritten until unless next pulses, next negative clock pulses will come. Until unless it will not overwrite. So that guarantee who will give? This transmission T1 get completely turned off. Up to that I need to be maintain the data same. It should not be changed. If it is changed, then it will overwrite. If I will maintain the same, it will not overwrite, right? So how I need to maintain that one? Means that is the only time we'll call the hold time. That is the only time. T1 off time. Okay? T1 off time. So not only T setup time for data to be stored properly. So I also need to be consider T hold time equal to T1 transmission gate off time. Until unless this transmission get off, it goes to the off. I need to maintain at the D input same data. I need to maintain the D input same data. Means after the clock edge also certain time I need to be ensure that my data is not changed. My data is not changed. This is called the T hold time. Okay. T1, okay, transmission gate off time only called the T hold time. So if the definition is observed, the minimum data, so the minimum time data should be stable after active edge of the clock. The minimum time data should be stable after active edge of the clock. That is the T hold time. So this is the T hold time. So the why that minimum time is required to be stable means, okay, this is when it is going to T1 is going to off condition, any other data will comes and override. So then what happened? So neither 0 nor 1 conditions can come. So okay, so data can be overwritten with the new data can chances will be increases. Okay, new data will go overwritten to previous data, that kind of chances will be increases. So that's the reason. So that is the reason what we will do. So we need to be ensure that okay, this T1 is completely off. Go to the off. So that time is hold time. Means to make one data is properly stored in the flip-flop. Okay, so you need to be T setup time plus T hold time. T hold time. This both time if you made, okay, so then I can guarantee that my data is stored. Okay, next pulses, okay, it will be processed to the output side. It will be go to the output side. Okay, one negative level, one positive level, one negative level and one positive level. It will passes to the output side. So that I can guarantee. Clear? Clear. So this data will be passes next. So this T2 is turned on, so T1 is turned off, okay, T3 is turned on. So then when it is T2 is turned on, so what happens, this inverter 1 will be turned on, okay, so 0 data becomes 1. So then it will passes to this transmission at T1, so 1 only maintain. So this 1 will goes to here, this 1 will goes to here, okay, it will go to output as well as it will go to the inverter 4. So when inverter 4 it goes, it is go to the latch mode. So next case what happened? Next case when immediately data will be changed. Okay, this one only continuously keep on will be goes to the output. So whatever previously stored data it will goes to the output. New data is ready to enter into this. Okay, this master latch. Okay, slave latch always give the previous data to the output. So new data ready to enter into this master latch. Again, I need to be check, okay, T setup time, T hold time, it is meeting or not. Okay, so then I can guarantee that okay, the data is properly meeting. I need to be ensure that okay, data 0 as well as data 1 both are okay reaching properly. These are the things. Clear? Any questions here? Any questions? Any doubts here? T hold time is the minimum time. The minimum time data should be stable after active edge of the clock. That minimum time only T transmission 1 get off time. Transmission 1 get off time. So these are the so definitions. Now I will give one simple example. So normal case of example I will tell you. So then you will understand. For suppose consider. So you are at okay. You are in Bangalore. For suppose you are in at Martali. Okay. So you are at Martali. You need to reach to the bus stop. From the bus stop, okay. So after that, okay. So from your room to so bus stop, okay. So there is a time. There is time taken is there. Some time taken is there. After reaching the bus stop, okay, you need to be get into the bus, right? Get into the bus. So when I can say my journey will be succeed. When I can say my journey will be succeed. First I need to start from room or home. I need to be start. After that, from the room to be okay. Whatever the bus stop, the time taken is there. Okay, the time taken is there. So for suppose consider bus will come at 10 a.m. From your room to okay bus stop. So it will take the time will be take okay For suppose 30 minutes time will be take. 30 minutes time will be take. So when you need to start? When you need to start at the room? 9:30, right? So when you start at 9:30, then only at bus stop you can reach to the 10 a.m. time. You will be on time. You will ready for the catch the bus. Catch the bus. Bus is came. Bus is came. If you are enter, okay, if you are get into that bus, then only so you will go to the your destination. Then only you will go to the your destination. Now, if you are consider okay 10 a.m. bus stop, 10 a.m. bus will comes. So if I will start at 10 a.m., I will start at 10 a.m. So I will get into that bus. No, because the delay is here. We have the delay. The delay is here. So now a person who started from the room, he need to be a same mindset that I need to be go to some destination. He should not change his mindset. He need to be same mindset that okay, I need to go to the some destination, some X destination. So he started from his room. 30 minutes he need to travel. So then bus, okay, when bus will comes at 10 a.m. But you have a delay 30 minutes. That's why you are starting at 30 minutes before the bus will comes. Now, so simple. This same technology if you apply here, okay, bus is a clock. Bus is a clock. Person is a data. Person is a data. Before the clock only, the data should be stable. I'm saying before the clock only, before the bus coming only, bus stop. So that the person, whatever the person is, he should come to the bus stop and he should be stay there. Then only he will get right. He came to the bus stop and he went to somewhere, okay, to drink something or somewhere. So buses came, he is able to catch. No, right? The same thing, okay, he need to be come to the bus stop before the bus and he need to be stable there. So then only he can get into the bus. So that's what only the setup statement. Okay. The minimum time data should be stable before the active edge of the clock. Why the data should be stable? The time taken from room to the bus stop, how much time is taken? The same way the time taken from the D to this inverter 2. It is taking that much time. Means it have the delay. In this path will have the delay. So the delay is there. That's the reason I need to be start. Data need to be start earlier. So data need to be start earlier. And when clock will come, okay, it should be stable. It should not be changed. So then, so clock will come. Clock will be pushed this data to. So next stage it will push. Means the same how okay bus is come. If he will catch that bus, then it will go to the next stage. So now see. Now he catches the bus. Okay, that person catches the bus. After catching the bus, he need to go to the X. Okay, he need to go to the X stop. Okay, destination is his X destination. But before that X only, we have one more destination. Y destination is there. If suppose he drop at Y destination, he will reach to X destination. No, right? No, right? The same thing here also. So when he catch the bus, he need to be stay in that bus until unless that bus will be reached to the X destination. The same way, after clock is reaches to this inverter 2, this data should be stable until unless this transmission gate T2 will be turned on, transmission gate T1 will be turned off, completely turned off. Okay, when it will completely turn off, okay, so then only, so it will be reaches to its destination. This data will be reaches to this destination Q. Getting? It will go to from here to like this Q. So that is the thing. Okay, so the time which is okay, it is stable in that bus stop. Means in that bus, how much time it is staying. That time only called the hold time. The minimum time it should be stable. Okay, that time only called the hold time. Okay, so this is the thing. This is the how the data will be processed in the flip-flop. Very important. in your entire the life as a PD engineer, you will heard this only two terms, okay, with respect to timing, that is setup time and hold time. To meet these two times, okay, your life will be gone. Means you always try to make the setup time. When you are meeting the setup time, hold time will be fixed. When you are trying to meeting the whole time, setup time will be fixed, okay. Like this, it will be there. So you need to approach the process that, okay, so how I can meet setup time without fail the whole time, how I can meet the whole time without fail the setup time. That is very important. If you understand this process, any questions, any doubts, very important topic, because so on top of this topic only, all the STA things will be there. All the STA things will be there. All the timing arcs which are expect to the flaps will be there based on this topic. This is very important. This is not required to be discussed in the digital. But why I explain these things in the digital means people will think that, okay, digital and STA are different. Whatever the STA timing arcs we are discussing, those are not related to digital. No, it's not like that. Digital extension only STA. In the digital, we will discuss about the logic gates, how the logic, okay, how the output is generating. But when that how the output is generating in that how output, okay, how much which gate, how much time it is taking, which gate, how much propagation delay it is taking. That delay calculation only STA. The delay calculation only called the STA. Clear? Clear? So very important topic this is. Understand? Any questions, any doubts, you can ask. So otherwise note down, okay, the definitions. So otherwise note down the definitions. Setup definition is, what is the setup time? Setup time. The minimum time. The minimum time. Data should be stable before active edge of the clock. That active edge may be positive edge or that may be negative edge, anything. The data should be stable before active edge of the clock. That is the setup time. Hold time, the minimum time, data should be stable after active edge of the clock. That is the whole time. So in the equation format, if I want to say what is the setup time is, okay, transmission 1 on time, inverter 1 on time, or inverter 2 on time. These all three on time will be called, okay, setup time. Or simply if I want to say is, okay, so this next time when we go to the next extension, it will change, okay. So in the setup time T1, the transmission get on time for suppose consider 0.3 seconds, nanoseconds. Okay, transmission 2 off time will be considered it is 0.2 nanoseconds. Setup time always they will take, okay, higher value. For higher value they will take setup time. Means even, okay, in the equation I'm saying inverter 1 on time, inverter 2 on time, inverter T1 on time also. So setup time always they will take, okay, worst case. Worst case. Why they will take worst case means, for suppose consider same thing. For example, I will say. So from the room to bus stop, to reach the bus stop, okay. So it will take, okay, minimum time it will take 30 minutes. Worst case, okay, if traffic is there, it will take 40 minutes. 40 minutes. 40 minutes. Traffic is there, then 40 minutes it will take. So at 10 a.m. I have a bus. I want to be guaranteed I need to travel to the, okay, some destination, some X destination I need to guarantee to travel. So when I need to start? When I need to start? I need to start at 9:20 only. 9:20 only. Worst case it is. Means if I will consider worst case 40 minutes traffic also there, so then I can reach to the bus stop, okay. So within the on time, I can reach to the on time. The same thing here also applied, okay. So what they will do in the next when we discuss the same topics, when we discuss the timings, so they will consider the worst cases. They will not consider the best case for setup. And quite opposite to the hold, they will consider the best cases. When best case consider, only data can come to the faster and enter to the inside. So when the data is faster also, I need to be prevent that situation. I need to be prevent that situation. Like that I need to be made. Getting? So those are the things, okay, we'll discuss in the next class very clearly. So means upcoming classes, STA related classes, we'll discuss. This is the setup and hold time related to flip-flop. So now, so if I want to clearly explain the timing arcs of the flip-flop, if this is a flip-flop, okay, D flip-flop, this is a D, this is a CP pin, this is Q pin, this is Q bar. So Q bar they will use or they will not use, that depends on their requirements. Okay. So reset pin will be there, reset, set will be there, The how the timing arcs will be means, okay. So from D to CP will have the two timing arcs will be there, two timing arcs. So if you observe D2, okay. D2 what happening? D2 CP pin. CP pin means okay, this CP pin, okay. Transmission 1 CP pin, transmission 2 CP pin. Two timing arcs are there. What are those timing arcs mean? Setup and hold. Two timing arcs will become, okay. Setup timing arc, hold timing arc. From CP pin to Q pin propagation delay, TP propagation delay means, okay. So from CP pin means this transmission get to Q pin propagation delay means, okay, this transmission 2 on time, inverter 1 on time, transmission 3 on time, inverter 3 on time. This is the propagation delay. This propagation delay only called TP. Clock to Q, CP pin to Q pin. So these are the timing arcs will be there. The same way, reset to CP pin, reset to Q pin. Okay, reset to CP pin. So here we will have recovery time, removal time. So this will discuss, okay. When we started STA, we'll discuss what is this recovery time, removal time. Same as like the setup and hold time. One small definition will change. Same as like the setup and hold time, but small definition will change. So this recovery removal time will be there. The same way means there is no timing arc between D to Q. This is the one interview question they will ask. Why we don't have timing arc from D to Q? Why we will have timing arc from D to CP, CP to Q? So then you need to draw this and you need to explain that, okay? Okay? So the data will be stored, okay? Transmission T1, inverter 1 and inverter 2. After that, transmission 1 will be off, T2 will be turned on. From the T2 to it will be inverter 1, T3 and inverter 2 and it will goes to outside. So means first, okay, negative pulse will come. Negative pulse or positive pulse will come. Point opposite pulse next time will come. So in this condition, few transmission gets turned on. In this condition, few transmission get turned on. And the clock will be made to be, the data should be reached to the output side. So that's the reason there is no direct path. So the path will be transmission get to inverter 1 to inverter 2. After that, transmission 2 to inverter 1, transmission 3, inverter 3, it will reach to output side. The path will be divided like this. So the timing arc when you observe, D2 setup timing arc will be there, D2 hold timing arc will be there to CP pin. From the CP pin to Q pin, propagation delay will be there. Clear? So this is very, very important. These timings arcs are very important. You will observe this timing arcs in the .lib file. So this is one of the files, one of the input file for PNR, placement and routing. One of the input file .lib file will be there. Any questions? Someone unmuted. Okay, so please, if you have any questions, you can ask. Otherwise, mute. Nandini, you have any questions? So this is the complete thing. Okay, how the data will be processed, how the data will be shared. Okay, what is the setup time, what is the hold time? just I given the introduction like a trailer for the setup time and hold time. So the setup times different cases are there, hold time different cases are there. So different calculation methods also there like okay OCV,